Hi everyone. So Dr. Satpata here. We are talking about the course for third year chemical engineering on chemical technology, and here we are looking at sulfuric acid production. So sulfuric acid production has three parts to it. One is a sulfur getting converted to SO2. Part 2 would be SO2 getting converted to SO3, and part 3 would be SO3 getting converted to sulfuric acid. So in this particular video we are looking at the first part, how does sulfur get converted to SO2, sulfur dioxide, what are the challenges, what are the conditions which goes into it. Okay, let's start. Our objective is to get finally a sulfuric acid production which should have a concentration of 98.5%. With increase of technology it has gone to 99.5. It talks about specific gravity and other things which is required for sulfuric acid. Okay, now let's look at here. It talks about three major reactions. It starts with a sulfur and air as a raw material, which gives you sulfur, a reaction of sulfur and oxygen to give SO2, sulfur dioxide. Next part will be sulfur dioxide reacting with oxygen again to give sulfur trioxide, which is a very crucial reaction. And the last one is absorption of SO3 to give you the final product. Now let's look at here. When you speak of raw material, as discussed before, sulfur and process air, sulfur can be procured from the mines, or a refinery also can get sulfur as a byproduct which can be purchased and used. The process air actually contains 21% of oxygen, 79% of nitrogen, as we know, but it's the cheapest source of oxygen, so we use process air available from atmosphere freely. And for heating or cooling purpose there is a process water which is taken from water reservoir. Now when you speak of sulfur, there has to be a good purity of sulfur. Better, a more pure sulfur is preferred, so required purity should be at least 99%, and some small inert or contaminants would be okay, otherwise it will hinder your overall purity of sulfuric acid. Atmospheric air would be from atmosphere which is free. Now let's look at how does a sulfuric acid process develop. It started early with lead chamber process, then it got improved with research, and now presently they are started with platinum catalyst. Now it has come with a vanadium pentoxide. Okay. So this is the flow, but we are in this particular flow sheet we are only looking at the one part which is sulfur going to SO2. These are the reactions. The first for SO2, second for SO3, third for H2SO4, and so on. Now let's look at actual process. You start with a sulfur, a raw sulfur, which is called as maybe a dirty pit, because it is not, you cannot have a direct solid going into oxidizer. So what you do, you first melt the sulfur, then it has some impurities in terms of carbon or something, they won't be melted. It's only a sulfur will melt at around 130-135 degrees centigrade. So you take advantage of that, because sulfur is in liquid form, others impurities are not got converted into liquid, so you can just filter it out, and what you get is a pure sulfur, and you can store it. Now when you store it, you have to make sure that a sulfur remains in a liquid form. so that it can be very easily used, otherwise it will be difficult. Okay. So what you do, you store a liquid sulfur here. Now there is air, so you can use air filter to remove any contaminants in the air. Then you have the moisture will unnecessarily have a burden, so you need to remove a moisture. It can be removed in a drying tower where you can dry it by sending or contacting it with a concentrated sulfuric acid. Now air got dried, there is no water in it, but at the same time it was dried using the H2SO4, so it will carry a sulfuric acid which will again damage of oxidizer. So you need to remove that sulfuric acid mist, which is removed in a mist eliminator. It's a type of filter which will remove a mist which is normally a small water droplet, whereas air can be out, and it goes to a sulfur furnace where you contact sulfur which is in liquid form and oxygen which is in the form of air in a gaseous form, and so air is supplied in excess to make sure that the sulfur is completely oxidized. So it is actually a complete reaction. Now there is a requirement that sulfur has to stay in a liquid form. The feasible range, now there are two things. One is it has to stay in a liquid. Second, it should have a viscosity which can be easily handled. So at 130 to 145 degrees centigrade, it is observed that a viscosity is as low as 7 to 10 centipoise, whereas as increase the temperature, a viscosity increases, and it would be difficult for a pump to pump it, or amount of energy required would be more. So for this, the steam is used 3 to 3.5 kg, sufficient to keep sulfur in a molten form. You can see here in the sulfur pit inside there are coils which has a steam going into it, which makes sure that always a temperature remains above 135 and below 150 degrees centigrade. You can see when actually you oxidize the sulfur, it has to go as a fine spray so that it can be in surface area increase and it is a complete combustion is ensured. So this is a spray gun, a sulfur gun, which basically force the fine nozzles through which the sulfur is sprayed. It get into contact with oxygen at high temperature, get oxidized to sulfur dioxide. Okay, so this is regarding a sulfur dioxide. In next video, we'll talk about sulfur dioxide getting converted to SO3, followed by how do you make H2SO4. Thank you so much.